A stone is tossed upward at the speed of 16 feet per second from the top of the Leaning Tower of Pisa, the height of 185 feet. Neglect air resistance. Find the stone velocity as a function of time t in seconds. This is the projectile motion, and we learned that the position function for the projectile function is s of t equals negative 1/2 times the gravity times t squared plus v sub 0 t plus s sub 0, where v sub 0 is the initial velocity and s sub 0 is the initial height. Since the unit is given in terms of feet, the gravity that we will be using is 32 feet per second squared. Replace g with 32. We have s of t equals negative 1/2 32 t squared plus the initial velocity is 16. V naught is 16. The stone is thrown upward at the speed. Feet per second is the unit of the speed, which is in this case the velocity. S sub 0 is the initial height, but we were told that the stone is thrown upward from the top, from the height of 185. And so S sub 0 is 185. Simplifying this, we have S of t equals negative 16t squared plus 16t plus 185. This is the position function. To find the velocity function, we simply differentiate this. We get negative 16 times 2 is negative 32t plus 16. This is the stone velocity as a function of time t. The height of the stone is the position, but we found it already. And so for part B, the height is s of t equals negative 16t squared plus 16t plus 185. When will the stone reach its maximum height? We know that the maximum can be found using derivative s prime of t, and we found it. It is negative 32t plus 16. The maximum height is reached when the tangent is horizontal, and that is when we take the derivative and set equal to 0. Negative 32t equals negative 16, so t equals 16 over 32, which is 0.5. This is 0.5 or half a second after it is thrown, and that is when it will reach its maximum height. What is that maximum height? We simply plug 0.5 back to the equation. S of 0.5 is negative 16 times 0.5 squared plus 16 times 0.5 plus 185. And we see that this is 189. That is the maximum height. The unit for this is in feet. Lastly, when will the stone hit the ground? The stone will hit the ground when the position is 0, when the height is 0. And so we set the position function negative 16t squared plus 16t plus 185 equal to 0. Since the numbers are quite big, so we're not going to factor this, but we're going to use the quadratic formula with a equals negative 16, b equals 16, and t equals 185. T equals negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. If we plug this into a calculator, we will get t equals negative 2.937 and another t equals 3.937. Remember the t, the time after the stone is thrown, so we will simply ignore the negative time. When will the stone hit the ground? It is about almost 4 seconds after it is thrown.